On this problem, we are given data or survey as below. The question is, what is the probability that this manager has some good course background, given that the manager is a good manager? So first, this is a given. It's a good manager. What is the probability that this manager has some course background? So if we write this out as a probability, there will be probability has some course background. Given that it is a good manager. Right. So we will look for a good manager. That is the rating. So we will look at this. Right. Now I have to be a little clear here. When we say have some college, we mean only some college and not the college degree or the higher degree. So we just focus on the some college here. And out of the 39 good manager, 5 of them has some college background. So that will be 5 over 39. Of course, those with the college degree also has some college background, but we consider that different category. Right, next one. The manager of a used car lot took inventory, and this is the result. A car was randomly selected from the lot. Given the car selected isn't older than 2 years, so the given part is older than 2 years. Find the probability that is not a foreign car. Right. So probability that not a foreign. Given that is older than 2 years. Right. So there's quite a few things we have to worry about here. So first, it's older than 2 years. So it's going to be this. Yeah, except for that. And so the total will be 49 plus 23 plus 47. So older than 2 years together, 47, 23, and 49. That's 119. So out of those 119, we have to select this not foreign car. Not foreign, in this case it's just domestic. So we have to add all of this up. So out of those 2 years, older than 2 years, those 3 will be not foreign. So we're going to add those up. 26 plus 11 plus 22, and that's 59. So out of those older than 2 years given, that is 119. 59 of them not foreign. So that's what we get. Next, what is the probability that a region prone to hurricanes will be hit by a hurricane in any single year? The probability is 1/5. What is the probability that at least once in the next 5 years? So we talk about this in class many times. When we say at least once, we have to use the complement because it is easy to count the complement. So at least 1 is greater than 1. So what we want is the probability of at least 1 greater than or equal to 1. The complement of that is less than 1. And less than 1 meaning 0. So no hurricanes in 5 years. Right, now no hurricane in 5 years, meaning there will be 5 slots. And each year will have no hurricane. What we are given is that the probability that it will be hit by a hurricane is 1/5. So, but we want no hurricane in 1 year. It's going to be 1 minus 1/5. So I just say with the hurricane is, we should spell it correctly. Hurricane, 1/5. So if we have no hurricane in 1 year, it's 1 minus 1/5 is a complement, that which is 4/5. So in year 1, there are 4/5 probability that will be no hurricane. Same thing for year 2, same thing for year 3, 4, and 5. So 1 minus all that, which is 1 minus 4/5 to the 5th power, because there are 1, 2, 3, 4, 5 of them. Right, so just use that. And if we convert to fraction, that will be that. But I think decimal will be just fine. So that gives us 67.232%. Right. So simple is that. Yeah. So every time we see at least one, use a complement. At least one is less than 1, which means none in 5 years in this case. Right. You toss the coin 5 times, a fair coin 5 times. What is the probability? At least one head. So once again, at least one head, which is greater than 1. So probability of at least one head is equal to 1 minus probability of less than 1. Less than 1 meaning none. And at least one head, so meaning no head. 5 times, right? With the coin is tossed 5 times. Now, a fair coin is tossed 5 times. If we don't want head on the first one, there will be 1/2. There will be tail. 1/2 tail for the second time, third time, fourth time, and 5th time. So just like what we have earlier. So 1 minus 1/2 to the 5th, because 1, 2, 3, 4, 5 of them. And we have 0.96875. Or 96.875%. Oh, to the nearest 1,000. Yeah, so that's good. Or we could say 0.968 or 969 to a 10,000. Okay, so 0.9688. But it doesn't matter. That's what we have. Right, timestamp. Next, license plate in a particular state display 2 letters followed by 3 numbers. How many different license plates can be manufactured? Repetition are allowed. So there are 5 slots. We have 2 letters followed by 3 numbers. By number we mean digit. And there are 26 characters in the alphabet. and 10 from 0 to 9 digits, and each one the letters and number can be repeated, so and each one doesn't depend on the other, so just multiply straight across. 10 times 10 times 10, that is 1,000. Right, so that's very small number. Right. Next, a club elects president, 1, 2, and 3 different roles. How many different set of officers are possible if there are 14 members, and any member can be elected to each position and no repetition? Right. So there are 2 ways to do that. One is like with what we're doing here. There are 3 positions: president, vice president, and secretary. There are 14 members, so one of those 14 will be the president. The vice president, there's only 13 options left, and then 12 for the secretary treasurer, right? Because no person can hold more than one office. So 14, one of 14 to be a president, and then there will be 13 people left to be chosen to be a vice president, and then 12 to be the secretary treasurer. So multiply all of those, we have 14 times 13 times 12, 2,184. That's one way to do that. Another way is using permutation, because 3 different rows. That means when we select this, order does matter. Right? We choose the first person to be president, the second person to be vice president, and so on. The order does matter. Order matters. When we have these 2, we have permutation. In this particular, we're going to choose 3 different rows for 14 people. So in the calculator, 14 math, go to probability, option number 3. For combination, here we use permutation, so that's 2. And we do 3. And of course we should get the same thing. So there are 2,184 different ways to do that. Next, from A names on the ballot, a committee of 3 will be elected to attend a political national convention. Right, the difference of this one and the previous one is this is committee of 3 out of 8. This 3 order does not matter, because it does not say the roles in the committee will be different. If they have different roles in the committee, then that will be permutation. But since the people in the committee are interchangeable, it doesn't matter who we select first, second, or third. All 3 will go and do the same thing. So in that case, we say order does not matter. So this is going to be a combination. And we choose 3 out of 8. So 8 math, probability, combination is option number 3. And we have 56. A box contains 22 widgets, 4 of which are defective, 4 are randomly selected. Find the probability that, I forgot the timestamp, sorry. Right. Find the probability that all are defective and none are defective. In this case, we can just do that slot. None are defective. I think we did this one in class already. All right. So if we select 4 out of 22, order doesn't matter. So C4 out of 22 way to do that. So if we select just 4 randomly, regardless of defective or not, there's 4 combination of 4 out of 22. That's 7,315 ways to do that. Now, all defective, 4 of them are defective. That's to select all 4 out of 4, and we divide by this number. Give us 1 over, right? Because there are only 4 defective, we select all 4 defective out of 4. That 4C4. Now, if none of them are defective, meaning we're going to select 4 of them out of those non-defective. Since there's 22 total, 4 are defective, 18 of them will not be defective. So that will be the way to select for that non-defective, divide by the total. So we have that. And we can convert to fraction, or just keep decimal for the sake, 0.418. Right? So if we select just 4 randomly, that 4 out of 22 combination. If we want 4 defective, that out of the 4 defective. Non-defective, that out of the 18 that are non-defective, and they'll just divide by the total number. So that's what we have. I would take 1 divided by 7315. Alright, that is 0.12314. Right. So original decimal here, I move 1, 2, 3, 4 to the left. But of course, you can just give the answer in the fraction form. Be perfectly fine. Right, next. In how many ways can a committee of 3 men and 4 women be formed from a group of 12 men and 12 women? So this committee will have 2 groups of men and women. And 3 men are chosen from 12. And to choose the women, choose 4 out of 12. Independently, so we just choose this and that. And this is a committee. Once again, the roles are not important, or order does not matter. So we have 12 combination of 3 out of 12 times 12 combination of 4 out of 12. That's what we have. So it's just how many ways. So that's how many ways. Right, next. A committee consists of 6 people to be selected from 8 parents and 4 teachers. Find the probability that select 3 parents and 3 teachers. Right, so this 2 steps. This asks for the probability, so we're not just counting like this. Right, so a committee of 6. So the total number of possible committees eight parents and 4 teachers. So total will be 12, and the committee will just select 6 out of 12. So this is the total number of possible committees disregard of the restriction of how many teachers, how many parents have to be in there. We just select 6 people out of 12. So that could be all parents or 4 teachers and 2 parents. Could be any combination. But this is the total possibility. So I have 12. Combination of 6 out of 12, that's 9, 24. Now, on this particular committee, we want 3 parents and 3 teachers. And so we can choose 3 teachers out of 4 and 3 parents out of 8. Right, and that gives us there are 224. So there are 224 possible committee of 3 parents and 3 teachers over the total possibility of 924. So that is the probability of three parents and 3 teachers. (224) over 924. Right? So he will just pick any 6. He will pick 3 of each. So, and 224 divided by 924. And convert this to fraction. 8 over 33. If we want decimal, that would be 0.24. or about 24.24%. Right. And with that, we stop the review here. Thank you for watching.